today I'll be talking about my PhD project on engineering systems design in healthcare, which looks into smart mobile and wearable technology for support and monitoring in dementia rehabilitation. So let me start by introducing the team. I'm Julia, the PhD student behind the project, which was supervised by Professor Anja Meyer and by Husa Forshammer. The project was co-funded between the D2 Management Engineering and Rigshospitalet Glostrup, and we're also supported by collaboration with VTech and with Cachet. So to introduce you to the topic, I'd like to start by telling a short story inspired by some of the characters that we've encountered in this research. So here we have Anna and Peter. Anna was recently diagnosed with Alzheimer's dementia, and she's struggling with some of the changes in her lifestyle. She finds that she doesn't get to go out as much because she can't follow her weekly book club. She makes mistakes when she goes out and does grocery shopping, and she used to enjoy long walks with her dog, but now she's becoming increasingly afraid of getting lost on the way home. Peter, her husband, is worried about Anna's safety when she goes out alone, but on the other hand, he's also worried about the impact that all this time being stuck at home is having on her mood, and he's seeing signs that she's becoming depressed. So they've called a dementia consultant from the municipality to talk about some of these problems they're having. Now, the dementia consultant arrives, and she needs to spend a lot of time asking questions to understand Anna and Peter's lifestyle, how this is changing. And this can be difficult because Anna might not recall specific details of when she got lost 2 weeks ago, and Peter might not be able to be that open and frank with Anna sitting there. Once she leaves, it can be hard for the dementia consultant to really know whether her suggestions that she gave have helped, how things are changing, and she might not hear from them for quite a long time. So we recognize great potential for technology to play a role in this scenario. We see that our everyday technologies are helping us to remember information or find our way, but increasingly, these are also generating rich sources of health information that could provide information to somebody like the dementia consultant to understand lifestyle and behavior. So the goal of this project was really to examine the role of mobile, wearable, and wearable technology in healthcare systems for supporting patient quality of life and also for supporting care practices. So the end result of the project, to give away the ending, was that we've come with a novel solution to augment dementia rehabilitation by using everyday devices to provide both personalized support to patients and to monitor their behavior. So just an outline for the remainder of the talk. I'll start by going into the background to the project and our approach. I'll then take you through the results, the process used and the results obtained along the way. And I'll end with a conclusion and a brief discussion of the implications of the work. Okay, so back to the beginning. Today we can see that advancing technologies and increasing pressure placed on healthcare systems is really fueling a paradigm shift in healthcare. We can see we're going from a centralized, conventional care model that is very much focused on diagnosing and curing disease, and where care is delivered in discrete events in the clinical setting, to a far more distributed P4 model of predictive, preventative, personalized, and participatory care, in which care permeates our everyday lives and is far more focused on maintaining and enhancing well-being amongst people. So this P4 framework that describes this future care scenario, this can be a very challenging undertaking when it comes to designing the future healthcare systems. And we really recognize in this project that it requires cross-disciplinary effort. So in this project, we look at three main relevant domains to designing future P4 healthcare systems. The first being engineering design, which offers systems approaches that can deal with the complexity of future healthcare systems and recognizes their socio-technical nature. We also look at the technology and data sciences, where we see contributions in the form of these essential building blocks that really enable remote care and provide the tools necessary for generating the health information upon which it's built. Then, of course, the health and clinical sciences, which provide the fundamental knowledge about disease trajectories and treatment, which are essential to building these systems. The PhD project intersects these domains and aims to synthesize them in the research. And we also recognize that the P4 healthcare framework intersects all three domains. In investigating using these domains in the project, we also identify some key knowledge gaps to be filled in each of these areas. We see that today, engineering design approaches really need new ways of integrating these new data sources into future healthcare systems. When we look at the myriad new health technologies coming out every day, we can see that there's a lack of clinical implementation and limited understanding of user acceptance, particularly among elderly users who aren't the young health enthusiasts. Then when we look over at the health and clinical sciences, when we look at practice today, there is limited implementation of some available technological tools. And when we look at dementia specifically, the use of assistive technologies is quite sporadic, and the treatment of technology for support and for monitoring is often separated. So this gives a broad perspective of the project's topic and the three main domains in which we investigate this work. But in the scope of this PhD, we have really focused in on dementia as a concrete case in which to investigate these topics further. So why is dementia so important? Well, the prevalence of dementia is rising dramatically and is set to triple by 2050. The consequent costs globally will already more than double by 2030. And the World Health Organization, who have published these figures, have recognized that this could really overwhelm health and social services. Dementia affects memory, but also cognitive abilities and behavior. And since there's currently no cure today, this requires lifelong management. So overall, this doesn't just affect the individuals, but it affects their families who are looking after them and societies at large. And therefore, there's an increasing call for solutions that really focus on function, as in an ability to function in everyday life activities, and engagement, so social inclusion and being an active participant in one's society. Now, when we look at the clinical sciences, we see something like dementia rehabilitation, or rehabilitation generally, provides a very good starting point. Here we have a care approach in a simplified view, where a healthcare provider, some form of, it could be a neuropsychologist, for example, works together with a patient and their caregiver in a collaborative way to identify individual needs and come up with coping strategies to meet those. And this strategy might be reevaluated on a regular basis based on information about the person's status that is obtained through some form of assessment. So that's a good starting point. In this project, we want to look at how this could be expanded and augmented and supported by technology. So here we see that our everyday devices could provide an additional support arm, but it could also provide a channel for monitoring to provide objective, continuous information for this form of care. So this opens an opportunity, but it really raises some important questions to be addressed. Like, in our first two research questions for the project, we want to know, well, how can these technologies actually support patients in everyday life? What needs might they fulfill? How can data generated by these devices actually inform care practices? We also need to understand if we provide that monitoring and that support, what does that actually mean for quality of life among people with dementia? Okay, so moving on to the research process and the results obtained along the way. This culminated in 3 journal articles, which I will refer to as we go along, and you'll see the reference where you can find more details, and this will be a brief walkthrough the process. So to give an overview of the whole process, this can be broken up into 3 main phases of the research. First was an explorative phase where we really wanted to go out and understand current dementia care practices, identify some opportunities for technology to contribute, and use that to define a proposed future scenario that incorporates technology. This could then inform a create phase where we wanted to develop a technological solution that fit that proposed scenario. And finally, we wanted to evaluate the entire setup to really understand its clinical and technical feasibility. In each of these three phases, we try to involve caregivers, patients, and healthcare professionals the whole way along. And that sort of directed our choice of methods in each of them. So let's start with our explore phase. So at this point in the project, I wanted to understand the dementia care network and the various roles and needs within this. So I conducted a field study at the Dementia Memory Clinic at Rigshospitalet Glostrup with Eva, I can see us here today. So during this activity, I wanted to use a variety of activities that could involve a whole lot of different perspectives. So I interviewed several healthcare professionals. I shadowed them in their work in order to sit in on consultations with patients and caregivers. I also attended staff meetings and went out with dementia consultants on home visits in the partner municipalities to hear patients talk about their problems at home. And what I learned through this process was to understand what does care look like today. And here's a sort of typical care journey, which of course won't be the same for every patient, but here's a simplified view where I started to look at what is the care process for somebody going through the clinic. And along the way, I could then identify some important needs. And what I saw was that once a patient's diagnosis and treatment plan has become established, we then see several points thereafter where healthcare professionals need a lot of information about the status of that person and how things are going at home. From the perspective of the patient and the caregiver, once they get home, they need support with their everyday life tasks. They also need to feel safe, and they need their psychosocial needs to be met, meaning they need support for their mood and behavior to stay on track. So having finished this activity, I could then go and review literature to confirm whether this agreed, and also to start to identify opportunities for technology to fulfill these types of needs. So based on a review of literature describing assistive technologies for dementia and also describing monitoring using data from pervasive technologies, I could see that on the support side, there were collected examples of how pervasive technologies might fulfill some of the needs that we'd identified. These might include things like navigation support, calendar and scheduling, storing information. There's quite a variety. When it came to the monitoring aspect, we could see that, well, data commonly available from pervasive technologies includes such streams as location and activity. And what could this be used for? Well, activity provides an indicator of function, and perhaps activity is the better known type of data, but location provides rich information about a person's mobility, and specifically their life space or out-of-home mobility. And there seems to be a growing body of research documenting that people, elderly people, and especially cognitive decline, is associated with an impact on out-of-home mobility. And we can really see that there's a likely connection between these two. When somebody is able to function and do the tasks they typically do, when they feel safe going out of the home, and when they have a positive mood, it's conceivably likely that they would get out of the home more and be able to carry on life as normal. So we could then move forward and start to create the technological solution required to perform these support and monitoring activities. So the first step was to go out and actually find some devices and apps and test them among users. So in this activity, we selected an Android smartwatch and smartphone, and we found a selection of applications that could provide some of the support needs that we'd identified. We went and tested them with 5 participants who had dementia, and their caregivers were involved. And we used both controlled usability tests in a lab environment, as well as field tests where the participants went out and used the devices for 2 weeks, so that we could then interview them and collect data to analyze both usability and usefulness and overall user acceptance. So to summarize what we found in this exercise, the key insights were that familiarity and personalization were really important when it comes to user acceptance. We also decided that the watch didn't work as an input device to interact with, and should be used as an output-only device going forward. And we also saw that the calendar and scheduling functionality had the best impact in terms of being both widely useful to most of the participants and usable. I think I'm going to just turn off the... Can everybody hear me right without the mic?
Yes.
Yeah? It's making a bit of a strange noise.
You can try adjusting.
It's all right. I think everybody can hear me. Okay? Yeah. Okay, so then we moved on to the behavioral monitoring, where we wanted to develop algorithms that would be able to translate this location, steps, and activity data into meaningful measures of mobility and activity. Now, 2 important requirements for this were that we wanted it to be a pick-up and use solution that could just be put out there and be used with real-world data so that others could take and build on this work. We also wanted to be suitable for the intended use and users. So we're talking about monitoring lifestyle among elderly people with cognitive impairment. It shouldn't rely on them having to use the device in a very specific way or having to use it a lot. It also doesn't need to measure very precise things about activity the way it might if we were monitoring an exercise program, for example. So the first step, if we look at the mobility, is to translate raw GPS data into travel trajectories, meaning a series of stays at a location and moves to the next location. So if we have the output of that algorithm on the left here, we can see that somebody stays and then moves to the next place in a chronological order throughout the day. And that, together with the raw GPS points, can be used to calculate a set of measures. This can be the total size of the area around the points that they moved in. It can be the furthest distance from their home. And then there's several others listed below, including the time spent out of the home or moving around, or the number of places visited and trips between places. So this gives an overview of spatial measures, temporal measures, and also frequency or count-based measures of mobility. The next step was to go to the activity measures, and here we used recognized activities accessed through Google's API and selected those activities that were relevant and translated these into activity bouts throughout the day. And this helped us to measure, for example, how much time was spent active in a day. So the next step was to go and find out whether these actually worked, and to do that, we did some pilot testing. We had 5 participants use the equipment for 1 week, and at the same time, they logged their movements for that week using some log sheets. I've shown a little snippet on the one side, where you can see that they just recorded when they stayed somewhere, and then when they moved to the next place and how they did so. So what we saw when we looked at the performance of the algorithm was that if we showed the log sheet in black for when they stayed and moved, with the algorithm results in a dotted brown line, that there was overall agreement. And when they did disagree, this tended to be around 15 or under 15 minutes, which was the temporal resolution of the log sheets anyway. For us, what was important was that this could be used to actually measure the mobility metrics we were interested in. So when we look at 2 of the measures that were feasible to calculate from log sheets, which were time out of home and the unique places visited, where the worst scores are red and the best are in green, we saw that, yes, overall, on average for the participants over a week, the difference between the 2 was under an hour for the time out of home, and for places visited, less than 2 places. So we were satisfied with that. The activity bout detection is shown in the colors, which show the different types of activities, and the participants' logs are given in text above. And we could see that when they did move between places, the activity bouts were picked up. Two things to note were that we saw that for a particular move from A to B, the bout detection doesn't fill the whole time. So this could be real pauses in the journey, but we don't know that for sure. It could not be picking up all of the activity. There were also occasions where the activity recognition was incorrect, and this was confusion between bicycle and vehicle activities. So overall, what we learned from the exercise was that, yes, we could measure the mobility features, and that it was fine with our real-world data that had irregularly sampled points and collected just in their everyday lives. The activity bout detection, we thought, based on what we learned, was overall better for picking up habits and transport modes rather than very precise durations of how long they were in these activities. And the step count, which I didn't show you, we looked at both from the watch and the phone, and we saw that it tended to be higher on the watch, which may be because it was worn, so that was important to learn going forward. We also saw that while the steps continued to count while the device was offline, that this would result in spikes up. So that meant that it's good that it counts all the steps, even when offline, for a daily step count, but it won't show the distribution of those steps over the day. So it shouldn't be used for detecting bouts of walking activity. So having learned that, we could then take the solution forward and start to actually evaluate it among our target users. Before we took our technology and evaluated with the target users, we also wanted to include an evaluation that looked at healthcare professionals' perspectives on what we were doing. So here we held a workshop at the Dementia and Memory Clinic at Rehabilitation Glostrup with 8 healthcare professionals, and we introduced them to the measures that we were interested in and were in the process of developing algorithms for, and we discussed with them what value this would have for their work, if at all, and why or why not. And there we heard that overall there was agreement that both activity and mobility could provide useful indicators of health and function, and that overall trends were of greater interest than actual levels. We also heard some important concerns. One of these was data validity, so things like, well, are they actually lying there, or are they just not wearing a watch? Another important concern was the need for detail behind these values. So something like, well, a quote that we heard was, it doesn't show if they are lying awake and feeling lonely and scared. And really wanted to underscore this as an important point, because we don't see the technology as being able to provide all information. We see the technology as being able to enhance and facilitate this dialogue. So this is important to note, and we were glad that the healthcare professionals agreed and felt that we were on track and continued what we were doing. So the main part of the evaluation was the AWARE study, which was a series of case studies to look a little bit more in depth into the feasibility. Here we wanted to go out and use our proposed approach with people with dementia, so our target population and not healthy users like before. We wanted to really have real-world conditions where they would use the devices as they liked in everyday life. And we wanted to consider clinical implementation. So here we started to include some elements of dementia rehabilitation and get a feel for how this would work in reality in clinical practice. The 3 main analyses we looked at were data availability and utility. So do we actually get enough data to see anything interesting? Since today, a lot of this information is mainly obtained by directly asking patients, we also wanted to compare what the sensor-based measures were compared with what the participants themselves felt. And then we also wanted to take another detailed look at user acceptance of the technology and particularly the support. So who were the people that we investigated this with? Well, we had 6 case studies, and the inclusion criteria are indicated in blue in this list. They were recruited through the clinic, and it was important that they had actually been diagnosed with either mild cognitive impairment or dementia in the early stages of the disease progression. They should live with a caregiver who did play a role in our studies, and they should all live at home in the community rather than in a care facility. We were open to different levels of experience with smart technology prior to the studies, and we ended up having 2 with no experience whatsoever, and 4 who actually used a smartphone daily quite extensively before the study started. All right, so what did the participants do? Well, at the very start, we met them and introduced them to the study, and did several clinical assessments to evaluate function, quality of life, and baseline levels of activity and mobility. And we also sat and together defined an individual goal related to their quality of life. And this is taken as an element from rehabilitation. We then set them up with the devices, provided them with a user manual, instructed them on how to use everything and what they should do. But we also personalized this to how they wanted to use them. And here we tried to identify any specific needs that could be fulfilled and try to find some sort of app or tool that could fulfill them. Then the main part of the study was an 8-week period where every day in the evening they got a report on their phone to answer how active they'd been that day and how much they'd gotten out of the home. We also gave them a weekly call to check how things were going and to assess how they felt they had achieved their goal. And then there was ad hoc technical support and regular data quality checks run on the data coming in, which was all logged and analyzed. Then right at the end, when we wrapped up, we held a semi-structured interview to really ask them how it had been to use the technology and any of their experiences to help us understand user acceptance and impact. So let's start by looking at the data utility. Overall, we can say that we definitely got enough data to see what we wanted to see. The main problem that we encountered was with the watch, which dropped its connection very often, so we didn't get as much data as we would have hoped from the watch. However, since the phone measured all 3 of activity, the location, activity, and steps, it didn't seem to matter that much for the measures that we wanted. Over here we have, to sort of demonstrate this analysis, we have 2 different participants with the time of day going along the horizontal and each day of the study going up the vertical, where the color indicates how far away from their home they are. So 2 things you can see that we actually got quite a lot of data. There are very few gaps in this image. And we can also see that the data that we did get is able to reveal some patterns in behavior. The participant on the right has a very structured daily life compared to the person on the left. So we can understand that that might be used to sort of see a change in lifestyle as a structured day becomes less structured, which is relevant when it comes to people with dementia. Also, just to note that this didn't depend on how much the participants used their devices. Here we have screen on and off transitions for somebody who used it really a lot in blue, almost not at all in orange, and the green shows that they used it a lot in the beginning and this started to fade out over the duration of the study. But for all of these participants, we got enough data to see what we saw on the slide before. Then comparing the mobility and activity measures that we obtained from the sensor data with what participants felt in their daily reports, we have an example here where the red line shows their answers every day. If it's in the middle, they felt that their activity was normal, up being more and down being less. And then we have several different activity measures shown in green lines, where a combination of all of them is the thick green line. And what we saw when we looked at these for activity and mobility was that overall day-to-day fluctuations are certainly picked up and match between the 2 sources of information. But when there's something like here where there's a gradual increase in the sensor-based measures, that the participant could very likely just say normal, normal, normal every day, even though their normal is changing. When we go and look at the user acceptance, I try to condense this with a summary to show that of the 6 participants, we could overall say that for 2 of them, the acceptance was low. The circles with lines in are those that had no experience whatsoever with smart technology before. And the two who had low acceptance both had very active lifestyles, and both said in the interview at the end that they had participated out of curiosity and felt that they didn't really have a need for anything, that they were happy with their coping strategies and things were going fine. The dotted line is there because that participant actually used his phone a lot before the study started. And so when we're talking about acceptance of pervasive technologies for support in everyday life, he had already accepted this. But what we added in the study, he didn't really accept. He was happy with what he had before. And in particular, we gave him Google Fit, which he had some trouble using. So that's why we've put him in the low acceptance group. The medium acceptance group, they all benefited in some way from what we gave them in the studies. They found it fun, they found it motivating. But the two here who were iPhone users previously did struggle a lot with a change to the Android system, and that really affected how usable it was for them. But of course, this is not a realistic reflection of how this would be in future. The high acceptance participant, she felt that the support that we had introduced in the case studies had a very large impact on her quality of life. She had a lot of anxiety about going out of the home, and the support that we offered her, which was a tool to find her way home and location tracking for her caregiver, she discussed at the end a very big impact this had had on reducing her anxiety and giving her freedom back at the end. So to try and condense what we learned in this study, we can say that overall the data that we could obtain using these everyday devices in real life, they were able to generate the measures we're interested in and seem to be clinically relevant. We could detect day-to-day fluctuations in mobility and activity levels, and we were also able to reveal gradual trends that may not be perceived by the users themselves. We could also see that support from the smart technology could address some of the functional, memory, safety, and psychosocial needs. And again, we highlighted personalization and familiarity as being very key to acceptance among the participants. Okay, so moving on to some final conclusions and to discuss some of the implications. So now I'm going to try and take everything that I've spoken about today and try to condense this down to talk about what we see as 3 core contributions of the work. One thing that we've contributed with is knowledge about tools and technologies that are easily accessible and available today that can benefit people with dementia. And we've also included knowledge about factors that influence their acceptance. So who could use this? Well, on the one hand, there are dementia consultants. It is their role to, well, it is one of their roles indeed, to provide people with dementia with tools to support their everyday life. And they themselves have approached us and asked what tools might be available that could help the patients that they're in contact with. If we think about the knowledge gap mentioned at the start, there are designers of health technologies who could benefit from knowledge about user acceptance to help get these tools out there and implemented and accepted. We also contributed with, by developing a behavioural monitoring solution. We really tried to make this reproducible and scalable so that other researchers could go out and take it and apply it under real-world conditions with messy data. In doing so, we hope that we've contributed to, for example, the engineering design community regarding the knowledge gap that we mentioned at the beginning, this need to develop approaches that can handle these new types of data, and in general for understanding human behavior, which has been for a long time important in the design research community. There are also a long list of other health applications where information about mobility and activity are relevant. Other types of rehabilitation, for example, for people with stroke or an injury, a number of lifestyle-related illnesses, and then, of course, active aging. The list goes on, there are many. Then bringing these together, we have really proposed a novel approach to technology-supported dementia rehabilitation. And in this approach, we're combining both monitoring and support capabilities of new pervasive technologies. We've also demonstrated the feasibility of this proposed approach. So this is adding to the body of research on dementia care, and particularly non-pharmacological approaches, and those that focus on function and engagement, as was mentioned in the beginning, to be important. But we also see this as a step towards P4 healthcare. So to go back to the example that I gave in the beginning, to explain how this is advancing P4 healthcare, we can imagine Anna and Peter and the dementia consultant, and imagine a scenario in which they had the solution that we've described. Well, in this case, the dementia consultant could see a gradual trend in Anna's behavior towards lower mobility and flag a warning of onset of depressive symptoms, and it would help her to go in and provide solutions and suggestions to prevent that from happening. By providing these measures, which are visible to all involved, we are also helping to facilitate collaborative care, where Anna and Peter and the dementia consultant could look together and come up with a solution and a strategy in collaboration. We also allow them to target the solution that they're going to come up with to the specific need that Anna has based on this reduction in her mobility. And perhaps that might be the support that we've discussed, such as something to help her find a way if she goes out walking with a dog, or something for Peter to be able to see where she is, some way to remember her grocery list when she gets to the grocery store. There are these ways that pervasive technologies can introduce a sort of modular support that really targets the need that she has. So overall, I think that what we've learned in the research along the way is that these pervasive technologies, they are inevitable, and they are being used increasingly as an integral part of our everyday lives. So perhaps one of the most important contributions of this work, as we see future generations of people with dementia who will be using these technologies, is to be prepared for that future by really recognizing how these technologies and their benefits could be channeled and applied towards improving quality of life for people with dementia, and also improving the care that is delivered to them. I see I do have a bit of extra time, so I will go. I would like to take a few minutes to just talk about some of the future directions that we see as being important going forward. We do see that the research should live on, and we have identified some key things that could take the next steps. Our case studies, for example, have opened a lot of interesting questions that could be answered if we were to move on to larger scale and longer term studies that focus on some of the key points. We also really see a need for developing the data infrastructures required for clinical implementation. And just to use a little example from the studies, we really had a lot of difficulty with getting the regulatory approvals required to conduct our studies because of the issue of merging information from the clinic and from the hospital with information from technologies and from the technical research fields. So this is a real challenge that needs to be addressed if we're to move out of ideas and forward into implementation. A small one, moving over to some of the technical things, the Android and iPhone compatibility for a future study would be important to really get a deeper look at user acceptance with that challenge out of the way for users, considering that in the future they would just be using the devices that are their own. Then talking about how we could extend the behavioral measurement and the algorithms that are developed, we see an important need to start to look at pattern recognition and prediction. So we have a bunch of measures and we can see them change over time. How could we make this smarter to predict when is something going to go wrong, what is going to go wrong? Have we now moved from such a structured day to a not so structured day, and at what point do we need to step in and maybe measure some values to define how structured or unstructured that day is. And then, of course, last but not least, we really would like to investigate clinical implementation further. In our studies, we looked at some elements of rehabilitation, such as having a personalized goal for quality of life, that the participants should follow along the way, but it was by no means a full cognitive rehabilitation or dementia rehabilitation setup. So for us, the next phase would be to take everything that we've learned and apply it in a very realistic implementation of a care strategy for people with dementia in collaboration with neuropsychologists and other healthcare professionals that are involved in care for people with dementia today. Could also be dementia consultants, for example. So on that note, with a look to the future of the research, I'd like to wrap up and say thank you very much. I have certainly not done this alone. Eva sitting in the back from the clinic and the colleagues have really been a big help along the way, and it's really been a wonderful experience throughout. And so thank you very much for your attention.